Hey everyone, welcome to the Ri3D Redux Day 2 recap. I'm Benham from 2041 here with Ri3D Redux. So we'll do a little bit of an overview of each of our robots that we've got going on here, all the different subsystems, what's changed over the last day or so, give you some opportunity to ask some questions about the approach that we've done. Each robot's kind of developed its own little strategy as we go here, as we've kind of mix and match subsystems and figured out what's worked, and we're trying to do some different stuff so everyone can, see a couple different options that they can go for. So first of all, we're going to cover this robot right here with a single stage elevator. It's going to have an arm with a gripper on it as well. From a drive perspective, we're not going to talk a lot about that today because we overviewed it a lot yesterday and they haven't changed as much, but we'll do a little bit on the code side and what they've done since we talked last. As before, we're using Swerve Drive Specialties modules on both robots here. So they're great and they're performing well for us. And if you watch some of our other videos, you can see that they can get up the ramps pretty well too with a little bit of force. And you at home, if you tweak your bumpers around a little bit, you could probably make it a little bit smoother. We're calling it good for in our particular case, but if you want to tweak around with it, we'd suggest you play around with it. It's definitely possible.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. SOLIDWORKS is free for first teams. Over 80% of US engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity.
We're going to go through each subsystem on this robot. We're going to start with the elevator. So I'm going to turn it over to Chris.
Thanks, Ben. I'm Chris Herzog with 4292 and 4241. We'll talk a little bit about what's going on here. This is a little bit of a hybrid elevator. It actually uses a few Thrifty parts and a few Andy Mark parts. We wanted to try and check it out and get some experience with both. Both will work out really well. They're really easy to assemble. It's turned out to be a super smooth elevator. It's a pretty classic chain drive, a Neo down here. Something that's been new for us are these Rev planetary gearboxes and the right angle box. We are really digging them. They are easy to assemble. They're clean. You don't have to deal with a bunch of loose parts and getting grease on everything. And they're super easy to know what you're doing. Here's one right there, 5 into a 4 into a 4. This is going to be part of the drive mechanism for the arm, and we'll cover that in a second. But as you can see, we go through 2 stages of reduction into the right angle. We drive sprockets, connect onto the bottom of our elevator box here. Fairly classic design. You'll probably have seen this before. It's worked out great for us. And this is going to form the basis of the mount for our arm, working together with the cone grabber over there. What we're looking to do is we'll be mounted out and in a position where we can get vertical. We can get into a legal starting position so that we're able to get everything inside the frame of the robot, and we can also drop our arm down. We had originally thought about pneumatics. The geometry can be kind of difficult, so what we're going to be going to is a drive right here, sprockets, using a chain drive here, turning that. It's designed together with the elevator height change and the arm change that we're going to hopefully have a lot of flexibility to be able to reach and get that scoring into the second and possibly the third levels of the cone scoring. So again, this is been a challenge for us, is to make sure we can start in a legal configuration. A lot of moving parts, a lot of stuff. We're trying to really make sure that we can get everything tucked in and under control. So that's what we're doing on the elevator here and also on the arm. So Ben, you want to take back?
Sure. So this robot, like Chris said, we've got a gripper on it. We decided to descope for this robot, and we are just doing upright cones both on the floor and from the feeder station, and also the cubes, obviously, from anywhere. So I'm going to turn it over to Luke. Yes.
All right, from Pop Panel 1X, how long is the arm on the linear slider?
Yeah, so we're to some extent, and take me, tell me if I'm incorrect here on this one. We're kind of still figuring out exactly what it's going to be, especially after we mount the gripper. Yeah.
36-inch arm. The arm here is 36 inches. One of the things that, with the way we've designed it, riv nuts and the gussets, we can rapidly change the length of the arm once we get some real experience with it. We need to get the actual claw and the gripper on there. That adds length. We're going to have to work out how much room we need to actually score, because we're actually pulling the cone in, we're holding it, and we're pushing the cone out to score. So there's some distance in there that we need to take care of. You also want to, take a look at the field elements. Make sure that you can reach the things you want. Some of that's just math. Some of that's just scribbling on, on the CAD drawings and finding out kind of what length. But we're starting off with 36 inches from the pivot. And the pivot will be out a little in front of this so we can tuck it up. So it's going to give us a little bit longer of a reach. And with the elevator in the high position, we're just about horizontal for the highest cone score.
Yeah, and to note with this, we're going a little over long on things. This is a long arm for reaching out straight into to score on the high level. So after we get everything together, we'll decide if it makes sense or doesn't make sense, and we may descope just to level 2. Yeah.
And from Alton Cloak, what gripper are you planning on using on this robot?
Yeah. So I'm going to turn it over to Luke, and he's going to talk about that. Great segue.
Yeah, so my name's Luke, and I'm from Team 2481, the Robotics, and I'm here to talk about the gripper. So when he was kind of saying something about the cone mechanism, this is what we're talking about. So you may have seen the first iteration, which we revealed last night, and it was kind of a bigger, bulkier version of what this looks like now. It does very similar things as to where these arms or these fingers are kind of on surgical tubings, and we took out the pneumatic cylinders because there's really no need to run your air all the way up through to these fingers. The main idea behind this gripper is to be able to pick up the cubes in any orientation, because cubes are pretty easy. And then for the cones, we didn't really worry about the cones being tipped over. We wanted this to be an easy idea for teams who maybe don't have enough resources, just to kind of pick up the cone if it were in an upright position. So the idea of this would be, do you want to hold those? Yeah. So the idea for this would be to mount on the end of the arm that we were just talking about, and then it would extend down. If you want to pull the triggers. Alrighty. And it would kind of just suck the cone in, and you'd be able to grab it, you'd lift it up, and then when you set the cone down on the thing, you can just slowly release it, and it'll release the cone to where you need it to be. Same thing with the cube. The cube is very simple, where you pick it up and then you set it down. Can you demonstrate that? The cube? Okay. Go ahead. Pick it up, and then you put it to the height you want, and then release. So overall, a very simple mechanism. We kind of really dumbed it down to where it was originally on day 1 prototype. With the main goal being we wanted to be super simple for teams to not have to worry a whole lot about the complexity of flipping a cone up. You would just either grab it from your human player station, or you would take it up from the ground if it were upright.
All right. Thanks, Luke. And then with that, we'll move on to our second robot, where we're going a little bit more complex. We're playing around a little more with an idea that has more of a handoff, so we could potentially work with the cubes that are in sideways orientation. So there's a few more subsystems that are coming together on this robot. So I'm going to turn it over to Lucas. He's going to talk about our intake subsystem for this robot.
Yeah, so I'm Lucas. I am with Team 1736, and this is kind of, well, to date, it's the most successful intake for the mentality of if it's on the field, we want to be able to touch it, and then we have it, whether it's a cone or a cube. And so how this works is it's going to have a set of wheels or some kind of roller that is going to turn inwards, and then a bottom roller that's going to turn opposite, and that will create a suction effect that can deform the cube or the cone to be able to pull it into the robot, in which case we'll use a gripper on the arm that we'll talk about later to grab that game piece and be able to score it. And this cardboard box is kind of an idea for a trough that we've come up with, where since the intake has a bit of force behind it, it can launch the cone, and we're actually utilizing that. So if it lands on one of the slanted sides, it'll orient itself into a position in which we can easily grab it with our second stage. And some improvements from what you see. Obviously, we want it to be mounted. We want it to be pivotable so that it's legal in our starting configuration. And we also want it to be powered using a motor. But other than that, this is it's a well-designed prototype, and the design may stay very similar in the final.
All right, so the next action would be the handoff, and is Kevin around here? Oh, okay, Jack's going to cover that.
All right. So I think you could see from yesterday we made a lot of progress. Today we kind of slowed down, and with the reason being is one of the very important things that we're doing is we're using the boomstick. If you could hold that for me. So we're doing the telescope, pink arm. The big challenge here is trying to find the max height that we want because we need to find what height we want for the boomstick, what height we want for the extended stick, and when you make these longer, you want it lower, and then it's vice versa. So basically, you can only remove material. So we're being a little cautious to figure out how much room we actually need. All that room really is very dependent on where this cone will end up from our intake. So we're trying to stream both of them at the same time, but really what we need to start doing is dialing in our intake to figure out what orientation and how to make sure it's here in that orientation, so then we can figure out how much room we need for our handoff, where we're going to put just some pneumatic grippers on top of it, so we can then take the part, turn it around, and we're going to score backwards and try to really utilize the since we have a handoff, we really want to utilize of picking up behind us, because that's where all your cones are going to be, and scoring in front of you. We really think for autonomous that could be optimal later in larger strategies. And so what we're doing right now is we're really trying to figure out the handoff and the intake. And then once we do that, that'll lighten up our dimensions, what we need for the arm, where we're just going to select the height and then mount it there, mount our pivot point up. Right now it's going to be anywhere from 40 inches high to 32 inches high, depending on how much room we actually need for that game piece. And that currently is, I think, where we are right now. So most of the time, that development of this chassis has been been given to software that's done a lot of different that did a lot of different tasks today, and I can pass that off to you guys.
So in software, we've mostly worked on getting Swerve up and running, and we have done that. And the one slight modification we've made is we've chosen to not use the absolute encoders on the Swerve modules. So what the absolute encoders are used for is so they know the wheel's position even if the robot's turned off. So when you turn the robot on the next time, everything's already good to go. We think maybe there was an installation issue or something, and we're not getting good readings from our sensors, so we opted to not use them. So if you're doing Swerve at home and you're installing absolute encoders, be careful in how you position them and how you install them to make sure you get good data throughout your season. Past that, today we've been working on camera stuff. So here we have 3 cameras all running photon vision up and running, and we've got AprilTag detection working on those, and we have a camera doing AprilTag detection directly on the Rio. And with that, I'll hand it.
How are you getting the turn orientation now? If you're not using those encoders, what are you using instead?
Oh, instead of using the absolute encoders on the Swerve modules, we're actually using the built-in encoder in the Neo motors themselves to figure out where the wheel's position is. And this works great, and the only caveat is that when the robot turns off, it'll forget where its position is. So you have to make sure all the wheels are in the correct position when you turn on the robot.
Can you talk more about using the Rio for AprilTags and how that works?
Yeah, so in the past few years, solutions like the Limelight have been very popular to do vision with retroreflective tape because it's usually very slow to run on the Rio. And the new version of the Limelight and the latest version of Photon Vision both support AprilTags, so you can use those. But detecting AprilTags is easy enough that, like computationally, that it can happen directly on the Rio. And now you won't get results at 60 FPS, 90 FPS. It's closer to about 10 frames per second. So it's not really viable to detect stuff while you're driving at full speed across the field. But if you're just trying to align to place something, it's perfect because the moment you come to a stop, you're going to stop for at least a tenth of a second, and it'll pick up an AprilTag and let you know exactly where your robot is on the field. So you can align and place your cube or your cone.
From SparkleFox715, how are you guys planning to account for the tilt in the charging dock?
So there's two ways to do it. A lot of robots now have external gyroscopes and accelerometers on them, like the NavX or the Pigeon. And with those, you can get the degrees that the robot's tilted on any one axis. So you can use that to align yourself. Or the Rio actually has a built-in accelerometer, not a gyroscope, accelerometer, so it measures g-forces. And you can also just use that, and in practice it actually works good enough because you can just tell if it's 9.8 Gs, it's level, and if it's not, you have to account whichever way to get it back to 9.8 pointing down.
You mentioned, grab the mic.
Hi, I'm Kevin with Team 3260 Sharp out in Pittsburgh. One of the things that you might want to consider whenever you're mounting your gyroscope on your robot, so either your Pigeon, your NavX, if it's attached to your RoboRio, is keeping it square with your robot's frame so that you don't have to do any complex math to figure out which way you're actually facing, and having all of the degrees correspond to what you actually need to be doing to balance. If it's right in line with your actual robot, then it's going to be easy. You just need to deal with one of the axes on your gyroscope. Otherwise, you're going to need to start playing around with more and figuring out the math to actually do that.
One little thing I do want to clear up, keeping it in line can be very important, but a misconception I've heard a lot is that the gyroscope has to be in the exact center of the robot. You don't actually have to worry about that. As long as the gyroscope is in line with the robot, it doesn't really matter if it's in the exact center or offset a little bit. So you can see in the robot right here, our gyroscope's not in the middle. It's actually offset down a bit, and that's perfectly fine.
And you could see when we did the board, to make sure it was offset and in line with the robot, we just put it against the side of the frame to make sure that it was perpendicular with the frame so we could read those readings.
All right, question from Sid Rio. Any concerns with becoming high-centered on the charging station with Swerve?
So there are some concerns that I have personally with having the Swerve as is. If there's a robot that's already on the platform and it's balanced, and then you're driving up onto it, there's a possibility for you to become high-centered. What you could do if you think that's going to be a problem would be to communicate with your partners before the match. So you can talk with all your partners before the match, come up with strategies, and then say, hey, if we're driving up, just allow us to go ahead and unbalance it before we get onto the ramp. And then if you want to be able to do it even if your alliance partner isn't like maybe they get disabled up there or something, you could think about having something where you have like a U shape in your drivetrain, but I don't think that will be necessarily a problem that you can solve without just talking with your alliance partners first.
Hi, my name is Stephen Carmaine. I'm the head coach of the Livonia Warriors, Team 2832. And earlier today, we actually filmed a video of us trying to get up on the ramp. And I was the driver for that. We're using the MK4i Swerve corners. And while we were trying to go up the ramp, we noticed if you were going slow, it just doesn't have enough force to kind of go up the ramp. You kind of get your bumpers stuck on the incline on the way up, and then your front two wheels were floating, but you had enough on the back two wheels to back up and try again. It took about half power, around 6 or 7 feet per second, and you kind of ramped yourself up, and then once you were on the top, it was fairly easy to balance yourself and keep your position. We didn't try the multiple robots up there and see if it'll stay flat. It's definitely, you can't go up the ramp when it's already tilted the other way, but it was fairly easy to get up the ramp with the swerve corners.
All right, and for Draken, any concerns with durability?
I can't.
Yeah, I would say we are actively trying to make the things that we're showing here, trying to make sure that they're durable, especially the things that go outside the frame perimeter, that they've got some degree of rigidity to them, because we know teams are going to be looking at that and kind of looking at that for guidance in some cases. So we're trying to make sure that what we have here is pretty durable.
All right, and from Nick Jr., don't worry, I'm not skipping you. And how hard has it been to pop the cubes by driving into them?
Well, we've only popped one, it looks like, right? Someone who was actually there can kind of, talk through how this got popped. I don't know the details.
Okay. Yeah, so we filmed a video where we drove into various game pieces at slow, medium, and high speeds, and for the most part, they held up perfectly fine. Even running into an overinflated cube at full speed, it was fine, and it took a few attempts to even pop the cube. And even when we did that, even when we popped the cube, we used the side of the robot that had no bumpers, and so we hit the cube directly with the frame and with this sharp circular piece that's holding the battery down. So if this piece wasn't here, we wouldn't have even popped it on that try. So I'd consider it more of like a fluke scenario, because most of the time your bumper's going to hit it and it's perfectly fine. The only issue is if there's direct metal contact, like in a cutout or with an extension.
Hey everybody, before we keep going, we're going to start our giveaway for the evening, which is going to be for one of the official game pieces, or two of the official game pieces, a cube, and then also for one of the cones as well too. And on top of that, our friends at Andy Mark, who are providing it, have offered to have the Andy Mark crew sign it as well too, so you get a cool memento for the 2023 game. This is me delaying because I totally forgot to put in the keyword, by the way. So if you're interested in winning that, why don't we type in for our friend Goat here. What's the Goat's name? Kevin Jr. Okay, so type in Kevin Jr. in chat, and that's your keyword to win. One word, Kevin Jr., Kevinjr. Type that in chat. That's your opportunity to win. You're not going to win this one. Maybe we'll give that one away later, but you'll get a fresh... No, I guess we can't give that away. But we'll get a fresh cube and fresh cone for you. And don't forget, you do need to be following the channel in order to win. We do give our subs some extra luck because we rig it that way for them. But we got a few more things to go through, about another 10 minutes. So if you have questions, get those in chat, and then we'll draw for the giveaway near the end. So good luck, everybody, and we'll get back to our Ri3D team.
Yeah. We've gone through all the subsystems, so if we have any other questions, happy to take them.
Yes. All right. Some other questions. From Juxie, any concerns with Rev Swerve modules with the ramp, as the modules uses 3-inch outer diameter wheels?
Yeah, my comment on that one would be we're not using the Rev Swerve modules here in this particular case. Looks like a great product. I think they're really cool. So I haven't personally thought through necessarily there would be an issue with the engineering changes, with their particular engineering with what I've seen. Maybe someone else will do some testing on that one. But my personal opinion, I haven't seen any issue with it.
All right. And from Alton Cloak and Lucky's 301, they're wondering if we are using AprilTags and or retroreflective tape?
So we are using AprilTags. We haven't done any work on reflective tape. I'm not sure if we have any plans to do so. For now, we're just sticking with AprilTags.
And from the Eliminator, what Swerve modules are we using?
We are using the Swerve Drive Specialties MK4i modules. It is the L2 ratio.
Ben, looking into tomorrow, and then the reveal of this is going to be around, I think, noon or 1 p.m. Eastern on Tuesday as well, too. Talk to us about kind of what is tomorrow, what do you want to accomplish by the time we do our recap show at 9:30 p.m. Eastern? What do you want to have accomplished by then? And then I'm not sure if you want to spoil, but we might be in a different location on Tuesday as well, too.
Yeah. So there's a chance, it's probably pretty likely we'll probably be at 2041 shop because it gives us a little more space to move around. So we're looking at being there on Tuesday. By the time we talk to you again on Monday, we'd like to have both these robots fully complete mechanically and just working on software would be the ideal scenario. Hopefully we'll be there. We will see. But that is our goal.
From Timmy and GA, what gyro?
So we have the NavX on both robots. You can purchase it from Andy Mark.
Can you talk more about what the NavX is?
Yeah, so the NavX is basically it's a gyro that plugs into the MXP port on your RoboRio, so it's the purple thing sitting on the RoboRio for both of them. So we're using the NavX on both robots here that you can use essentially with your Swerve drive to know what angle you're positioned at.
All right, from Silver Lightning 4089, how fast is the elevator, or how fast would you like your elevator to go?
This elevator in particular has a 20-to-1 ratio reduction off the Neo. That's generally pretty good speed for elevators, I would say personally. We could go a little bit faster, but also this is from our perspective, this is a reasonable speed that I'd probably recommend for a lot of teams. It'll probably go up in 1 to 2 seconds to the top.
All right, another question from Timmy and GA. Did the SDS modules connect to the frame with rivet nuts as is, or did it require a modification?
So I don't have it right here. I think it might be behind. I can check real quick. Yep. I can post some pictures online, but pretty much what we had to do is the whole pattern did not match, but since we're building it in 3 days, we could not custom machine it. We wanted to make it 2 lengths. So we made a plate insert that fits perfectly to slip fit inside the tube. And I just used a countersink, a flathead cap screw that would help center it here. So we have the motion, so we lock it into position of the hole diameters, and then we also lock it in left and right. So that was just a quick adaptation we made to make sure it would work with the 832s, but that is because we are doing it in 3 days, and we didn't know what frame perimeter it was, and instead of the standard 28 by 31 inch, we ended up going with the 25 by 30 inch for this year's game to make sure we all fit on the platform. So that's just a fix we had to do with the rib nuts, but that's otherwise normally we would make those custom and just make them so they fit up.
All right, from SparkleFox 715, would you guys say a smaller drive base is better for this game or a larger drive base? And if so, what benefits do each give?
So the benefit of larger drive base is you get a wider area for your base that's essentially going around the field, less likely to tip with a wider base. Advantages, it's also easier to play defense with a wider base. So for a lot of teams, especially considering going with a wider base, if you might find yourself in the defensive role, probably isn't a bad idea. For having a smaller base, it'll generally make your robot a little bit lighter, might make it accelerate faster on the field, so your cycles could be faster. You'll be a little bit more tippy, potentially, but I think you'll see a lot of, and you'll have more robots that fit, obviously, on the platform at the end. I think you'll see a wide variety of robots this year, and both have their benefits for certain alliance roles.
From Alton Cloak, did you ever consider only picking up from the substation shelves?
Yeah, so the robot that you see here in particular is planning to pick up from the substation shelves most of the time, though it also has the ability to pick up upright cones and cubes from the ground because of the autonomous mode. So you could pick up extra game pieces if you wanted to, turn the robot around, pick up a second game piece, and drop. We probably won't get that far here in Ri3D, but we want to make sure the robot is capable of that.
From Penguin with Hat, what defense capabilities are there in this season that you suggest?
Yeah, so I think the defense is going to be pretty standard FRC lane defense. So there'll probably be either on the scoring side or on the pickup side, there's a cycle path that the teams are taking. So if you put a robot in the way of the cycle path, that's how you generally play defense and slow them down that way.
From Mickle24, any plans to handle or transport multiple pieces at a time?
It is against the rules to hold multiple pieces at a time unless you're in your community. Thank you. And it's unlikely in our case because most of the time you're going to have to go to the other side of the field in order to pick up those game pieces. It's only going to be if you miss game pieces that they're going to be extra in your community, in which case, especially when you get to the higher levels of play, we think that's probably going to be less likely. There's going to be a little bit of it, but it's not so much that it makes sense for us to design extra mechanisms around it. Yeah.
Something we did discuss briefly is if you want to, you could be a robot that simply takes pieces from other robots who delivered them to you in your community, in which case you could have as many as you want and just score them on loop. If that's a strategy you want to use, we don't want to discourage you. That's just not what we're doing.
All right, from the Eliminator, did you guys think about using a rectangular base instead? All right, did you guys think about using a... Okay, sorry, chat keeps moving on me.
Who's it from?
The Eliminator.
All right. Did you look at using a rectangular base instead of the way that, or did you use that so more robots could fit on the platform? I know, Ben, you covered that with the pros and cons, but what considerations did Ri3D have for that?
Yeah, so the second robot that we made is a 25 by 30 base. The idea would be that 3 25 by 30 robots could fit on the platform. So you'll see some extremely small robots. You'll see some big robots. This one's a little bit in the middle. The idea here, we really didn't want to compromise our holding a game piece and compromise our center of gravity by making our wheelbase too small. So we opted for something that's a little bit smaller, but not excessively smaller.
So the last question we're going to take for tonight, everybody. If you have more questions, we'll get to them just after the show on here. From Silver Lightning 4089, do you plan to go over the charging port during your teleop cycles, or do you plan to avoid it or go around it? What's kind of some of the strategy when you're looking at doing cycling? How quickly do you want to cycle as well?
Yeah, I mean, as far as how quickly we want to cycle, I think that there's a little bit of a function of driver experience and getting out there in the field and figuring out what that is. I expect that you'll probably see in this game on the high end, you might see as many as 12-ish cycles from some teams. On the low end, you're probably seeing more like 2 to 3. So it's going to vary. So we'll probably be somewhere in the middle with these robots. It's I think going over the charging port's going to be important for some of the cycles, just because you've got scoring zones behind there, and there's going to be people scoring on either other side of the charging port, so it'll get a little bit congested if you don't use it. So I think that's going to be kind of important. Yeah.
All right, let's go ahead, chat. We're going to roll for our giveaway. Once again, you got to be following the channel. By the way, if you're not following Funnery, you should be doing so. We have tons of great content coming up for you, both on Twitch and on YouTube as well. Tons. If you haven't seen the videos on YouTube, go check them out. Tons of Ri3D videos on YouTube that Ben and everybody else here have been creating. They've been doing such a phenomenal job here. We got a couple from Kettering University as well, too, so make sure you check those out. By the way, if you do win this, please shoot First Updates Now. That's me a message, either in Discord or here on Twitch, so we can get that Andy Mark Cube and the Andy Mark Cohen signed. We even got something from Andy Mark here. I heard he's going to personally sign it when he gets back to Andy Mark as well, so we're excited for that. So let's go ahead and draw for that winner, it's going to be Indy Sam. Congratulations, man. So a lot of us know Indy Sam, right? Go back
yes,
a long
we
way
do.
with him. Yeah,
Yes, we
so
do know
congrats,
Indy
man.
Sam.
Hope your build season's going well. And we'll any stuff to wrap up with, Ben, before we let you get back to work.
No, thanks for watching. We're being fast and furious here. If we don't get back right away, apologies on that. We're trying to make sure that we get great robots out for you, so you can check out how things go and see things work together and lots of cool stuff.
Yeah, we do have quite a few videos in queue that we're trying to process out. So the team is just firing them out. So if we'll get to some more tonight, as well as make sure you check them out tomorrow. We'll probably even have ones coming out even up to Wednesday as well too. So we'll let the R3 team get back to it. Good luck to the R3 team. Good luck to all you teams out there as well. And we're going to get back to building robots for you. So stick around, chat, ask some questions, and have a great time. Thanks, everybody.
All right. Thanks, everyone.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity. SOLIDWORKS is free for first teams. Over 80% of U.S. engineering schools and 370,000 plus companies use SOLIDWORKS to design great products. SOLIDWORKS can help you design a great robot on desktop or on the cloud. Go to solidworks.com/first to register your team. Thank you to all of our suppliers and sponsors for the Robot in 3 Days Redux and Kettering Bulldogs programs.